This is the video for the lesson for 8.2. So this is Big Ideas, Algebra 1, Chapter 8, Section 2. And as you can see from the very top, this is for a class on April 15th, 2021. And the title there in the middle is Graphing f of x equals a times x squared plus c, and Section 8.2. I'm not going to be stopping like normal note taking, because if you do need a pause, go ahead and stop the video and write down what you need to write down. So with that, I'm going to go ahead and I may break this into two videos towards the end because I would like to show some examples, but I'm not sure if I can adjust my screen viewing area, so I'll have to see on that. So starting out with this first section, I have right here Part 1 says graphing y equals x squared plus c. So in the first section of this chapter, we did graph y equals x squared, which, by the way, is the same thing as saying f of x equals x squared. And we saw that it was a U-shaped graph called a parabola. We also saw what a did to those graphs. If that number is larger than 1, it stretched it, so it made it more narrow. If it was between 0 and 1, it was a vertical shrink, so it made it wider. And then also, if a is negative, it flipped it down, and we called that a reflection across the x-axis. This is a fancy way to say that. So you can watch my other videos about that or look at your notes. So today we're focusing more on what C does. So as you can see, it's when you add or subtract a letter, and it turns out it's going to be a number at the end. So you can see this picture here, and this is one of those things you might want to pause just to copy down into your notes. So this first part says when C is larger than 0, so it's positive, this graph is a vertical translation of C units up. So basically, if it's plus 1, you would just take the parent function, which is the blue one, and move it up 1. So you move all of it up 1. Same thing if it is less than 0. That means C is less than 0, so usually it would be minus a number, but it could also be written as plus a negative. You would move the parabola down. Now the axis of symmetry would stay the same because you're not moving it left or right, but the vertex will be changed from the parent because you are moving it up or down. For example, on this red one here, the vertex would be at 0, c, which would be a negative number. And on the green one, it would also be 0, c, but in that case, c is a positive number. So summing that up, it says the c at the end of the equation moves the parabola up or down, and that is called a vertical translation. So next up, at the very bottom, I have two examples for you. It says graph g of x is equal to x squared plus x3, and h of x is equal to x squared minus 2. Then compare those graphs to the parent function, which is f of x equals x squared. So I went ahead and did this on Desmos, and I copied my results. So I'm going to scroll this down, and you can see what I came up with. And scroll back up or reverse the video if you needed to write anything down. So I put them all together. So right in the middle here is your parent function, which is, sometimes I call it the basic function. And I wrote it up here. F of x is equal to x squared. So it hasn't been translated up or down, it hasn't been shrunk, and it hasn't been stretched. So I also put in a bunch of points, not every single one, but a lot of them. So on this one here, we have an example of x squared plus 3. Notice I put these arrows in with a little plus 3 next to them. Basically, it's just pointing out that the difference between the blue parabola and the green parabola is it's just moved up 3 units. That's all it is. Then for the h of x one, which is x squared minus 2, I put an arrow going down 2 units. So you can see some of the points as we go along here. So like here's a red one. Actually, I'll focus on this one right here. 1, negative 1. If I go up 2 units, I would get the parent function. And if I go up 3 units, I would get the green function. Okay, so you might be asked to compare them, and so you should say, in this case, you would just be saying it's a vertical translation up or down. Okay, I'm going to move on a little bit. So sometimes you are also going to have to, I can't show everything right here, so I'll stop there for just a second. So graphing y equals ax squared plus c. So sometimes the parabola is going to be vertically translated and it's going to be stretched or shrunk. Okay, so in this example that I have here, I am doing that in my new g of x. As you can see right here, it's 1/2 x squared, and we saw from the last lesson that a number between 0 and 1 is going to be a vertical shrink, which means you're flattening out the parabola, which makes it wider. But also today, we're adding in this plus 3. So what that did, and I did this with Desmos, and then I just copied the picture, it moved the parent function up 3, but then these arrows I used to show that it widened it out a little bit. Because if you could imagine this green parabola move down, it would be wider than the blue parabola. Okay? So it's not just, you can see the plus 3 at the vertex, but you can't just add the other 3, like especially this one, 2, 4 and 2, 5. It's not as easy as just moving it up anymore because we're also widening it, except right in the middle, it's not being stretched. All right, so now I'm going to go ahead and open up the examples that I wanted to do, and I'm not sure if I'll be able to show this, so I will know in just one moment. And this is where I had to check to see if I could. No, I'm going to go ahead and stop my video here and then start a new one because I have to resize this. All right, it turns out I can resize if I just pause it, so that was a nice surprise. So I'm going to go to this. You can't see this one. I just published this for me. The actual assignment for you is just 5 problems, and I'm going to do 2 problems like them. So I'm going to click Enter. And it looks like I'm going to have to resize again, so I'm going to go ahead and do that right now. All right, so I resized, and you can see the problem in the upper left says identify the graph of h of x equals x squared plus 8. So I'm looking for a graph that's been moved up from the parent function 8. So even before I open up my graphing tool, I can eliminate this one because this one has been moved down 8 units. So it's not that one. For this one, well, the vertex is right still at 0, 0. I can eliminate that one. So it's really between these two. Okay, so they both have a vertex of 8, so they've been moved up 8. So I am going to go ahead and click on my graphing tool, which is what they gave me here. And I'm going to type in h of x. And I guess I must have my cap lock on. I'm going to redo that. H of x, there you go, equals x squared plus 8. Okay, so remember you can zoom in as much as you want, and if you want to see points, you click on, let me just close this, click on this button here that says Edit List, and then on the picture of the table, and you can see some points. So sometimes it's nice if you can pick out a couple here. So for example, I have 1, 9 and 2, 12. If I can find them over here, like 2, 12, if I go 2 to the right and 12 up, that would be right where that is pointing. So I can't, that's definitely not it. It's got to be this one. So 2 to the right and 12 up, that looks good. 1 to the right and 9 up, it looks halfway between 8 and 10. So this one would be that graph. And before I even do the bottom, I'll go ahead and check my answer, and you can see right there that it is correct. All right, next up, I want to answer this part here. So this does not have an A other than the number 1. So this has just been moved up or down. So this is a vertical, that's up or down, translation it's plus 8, so that's 8 units, and then the direction is up. Check my answer, and that's all good. There is one more that I have to do, so I'm going to go ahead and move on. And here we go. We have another one here. It says identify the graph of t of x is equal to negative 3x squared plus 1. Now, first off, there is a negative in front of that 3, so it can't be this one. It also can't be the upper right one because they're opening up. And we saw from the last lesson that if there's a negative in front, and this negative 3 is in front, it has to open down. So sometimes we get lucky and that eliminates 3 of our answers, but we still have to keep going because we have 2 that are opening down. Now I also see that it says plus 1, and if you notice here, they are counting by 2's here. This is negative 2, negative 4, so that means that's positive 2 and positive 3, so this moved up 3. It can't be the number 10. It's already got to be this one. Without even graphing it, I know that that's correct. Okay, so you can graph it if you want to, but you don't have to. If you can eliminate, I eliminated the top 2 because it's a negative out front, and then I eliminated this one because this one has been added or vertically translated up 3 spots. This one has only been moved up 1 spot. So I can go right ahead to the bottom. The graph of t is a so it kind of depends on which one. They're talking about a factor. So they want to ask, is this a stretch or a shrink? And the number, if that number is going to be bigger than 1, it's going to be a stretch. So, and it's also a vertical stretch. They want both of those words. We're not doing any horizontal. So it's not shrink, it's a stretch. And you can always check to see, hey, yes, I got that right. By a factor of, well, the number out in front there I know is a negative 3, but let's just put down a 3 for now, a blank. So what does it want there? A reflection in the x-axis. That takes care of the negative. That's what that negative is doing in front of the 3. And you can check your answer again if you want. And this is going to be talking about it's being moved up or down. I see this plus 1, so that's a vertical translation of how many units? Well, it's plus 1, so 1 unit, oops, where'd it go? Oh, I did get it in there. 1 unit up. I'll check my answer, and that's all good. So I've just done 2 similar problems, and there's 5 for you to do in the assignment itself. Remember, also on the Big Ideas online pages, you can watch videos, but keep in mind that when they do the graphs, they are going to be doing it by making a table and plotting them by hand. And I'm suggesting that you just go ahead and use Desmos, although as you saw from my example right here on number 10, you don't necessarily have to graph it. You can figure out what the answer is in some of these just by looking at what the values for A and C are.